Hi, and welcome to our first video segment on polynomials. We're going to be discussing the different types of polynomials, their graphs, and operations with polynomials, and finding their zeros, or where they cross the x-axis. But before we begin, please take a few minutes, read the narrative at the top of the page, just a few short paragraphs, and when you're finished, summarize them in 3 complete sentences, making sure to use correct grammar, punctuation, and spelling. Additionally, if you can think of an example of where you may have seen a polynomial graph in real life, jot that down, and then we'll share those ideas when we get together in class. Restart the video when you're done reading the paragraphs and writing your summary. We'll see you in a few minutes. All right, so let's begin. First off, a polynomial has multiple terms that contain positive integer exponents. So our exponents in our equations have to be positive whole numbers. Let's look at some examples and see what we think. 5x squared minus 2x. Do you think that is or is not a polynomial? Is a polynomial. I'm just going to write is a poly because it only has positive exponents. I should say positive integer exponents. What about 3x squared minus 2x to the negative 2? Is not, because we have a negative exponent. If we look at the square root of x minus 2, what do you think? Do you see a negative exponent, a fraction, a decimal? Well, this is a little tricky. This is not a polynomial because square roots can be written x minus 2 to the 1/2. I don't know if you recall that, but a square root is really the quantity to the 1/2. So we can't have any radical signs. Now I've got 5 over x cubed plus 1. What do you think? This one is not a polynomial because we have an exponent. Actually, we have a variable, because even if we had a single x down there, it would be x to the negative 1. If we have a variable in the denominator, because this 1 over x cubed is really x to the negative 3rd if we wrote it in that notation. How about 4x to the 0.3? Obviously not. Not a poly because it has a decimal exponent. Now I'd like to go over some vocabulary review with you, but just remembering that a polynomial only has positive whole number exponents. This is just simply a review of some vocabulary. We did this back in our Algebra 1 unit, but I just wanted to refresh everybody's memory. First off, terms of a polynomial are separated by addition. So in 4x to the third plus 2x squared plus 7x plus 4, this has 1, 2, 3, 4 terms. And they are 4x cubed, 2x squared, 7x, and 4. So I have 4 terms. Next, the variable represents that unknown quantity and is represented always by a letter. Now, the coefficient is that number hanging out front. It's the number multiplied or in front of that variable of each term. And of course, our constant is a number without the variable. Nothing new here, just a review of some of the terms that we've been working with all along. Now, here are a couple new terms possibly. Maybe you'll remember them from Algebra 1, but a monomial has one term, and a binomial has two terms, just like a bicycle has two wheels. Okay. Now, let's talk about polynomials a little bit. All our polynomials have degrees, and each term in a polynomial has its own degree, and that degree in a single variable polynomial, meaning it only has one letter, is the value of the exponent. And the degree of the polynomial is the same as the degree of the term with the largest degree or exponent. Let's take a look at our example. 4x cubed plus 2x squared minus 3x plus 1. I ask you to tell me what is the degree of each term. Well, let's list our terms. I have 4x cubed, 2x squared, negative 3x, remembering that those negative signs are stuck to what's behind it like super glue, and 1, which is our constant. So 4x cubed would be a third degree. 2x squared is second degree because my exponent is a 2. Negative 3x is a first degree. And constant is really considered degree 0. Because if we recall from Algebra 1, x to the 0, anything to the 0 power is 1. So we really have, this is times x to the 0. So that is of degree 0 if it's not written in. All right, now we need to know what is the degree of the polynomial. Looking back at your definition, the degree is that of the highest exponent. So this is a third degree polynomial. And how do we know? Jot that down. How do you know? So let's look at polynomials where we have multiple variables, more than one letter. So when a polynomial has more than one letter, like 3xy, the degree of the term is the sum, we're going to add them up, of the exponents of that particular term. And the degree of the polynomial is the degree of the highest, I didn't give us much space, degree term. So looking at our next example, we have t to the fourth minus 6s to the third t squared minus 12st plus 4s to the fourth minus 5. So what is the degree of each term? Well, t to the fourth is fourth degree. That hasn't changed. We have one term. Negative 6s cubed t squared. It's actually going to be fifth degree because I add my exponents. 3 plus 2 equals 5. So this is fifth degree. Next, I have negative 12st. Adding my exponents, remember when there isn't one written, there's always one. This is going to be second degree. Then I have 4s to the fourth. That's fourth degree as well. And then negative 5. That is degree 0. So we just add those exponents where we have more than one variable together. Now, what's the degree of the polynomial? Which one is my highest degree? Well, this polynomial happens to be fifth degree because it is the highest degreed term. It is the degree of the highest degreed term.